Even though they canceled it, you wrote.
All right, gang. Just a few things here about this week. So you know what's going on. So today's normal day. We'll talk about homework, all the homework that you had last week, page 4, 5, 7, and 8. We'll go over all those answers, give you plenty of chance to ask questions about any of the holes, asymptotes, intercepts, graphs, whatever you need to do. And then tomorrow is election day, so there is no school tomorrow. But if you do need help, you can contact me and we'll try to set something up after 12. And then Wednesday is our normal day off. And so I've got those morning meetings. And so again, if you want to see if you can schedule some help after 12, that's fine. Thursday, I have 12 of 22 of you that are saying that you're coming back face to face. So class will pretty much be the same. It'll just be a little bit longer. Class is going to be 90 minutes like it usually is when we're face to face in school. And then Friday in class is review, and we'll have a test that opens at 3:30, and you'll have the weekend to finish that up. Homework will be due Sunday. Test is due on Sunday. So you got plenty of time to get that done. All right, so we're going to look at homework. So homework from I guess it was, I guess this was Tuesday night, was graph pages 4 and 5, and then come up with the holes, asymptotes, and intercepts from pages 7 and 8. So this is the first graph on page 4. I'll give you a few minutes to look at it. You can ask me questions, do whatever you need to do to make sure you kind of have an understanding of what's going on. So if nobody asks a question, I'll give you about 30 seconds to look at it, and then we're moving on. All right, we'll move on to number 2. This one has a hole down here at -5, -1. So when you graph that hole, make sure it's an open circle. I can see through it. All righty, moving on to number 3. Number 3 got a little crazy.
Can you go over the graph for number 3?
All right. So when I erase this, the asymptotes are still going to be there. Are you good with the asymptotes?
Yeah.
Okay. So I'm going to zoom this up so that you can kind of see what's going to happen. All right. So you need 3 points minimum. You can have more, but you need at least 3. So the x-intercepts are 1/2 and 1. So they're really close together. And then you've got the y-intercept here at -1/12, which isn't much further down from those two. So I'm just going to put it right there. Now, this, you may not know kind of what's going on here, okay? And maybe you don't. So you can always come out and grab another x value. So this is 1, 2, 3, 4. So if I grab the y value 4, I'm sorry, the x value 4, and plug that in, it'll give me another ordered pair to graph. So I'm going to zoom this back up so we can see the equation. When you factor this, nothing really canceled. So I can take this 4 right here, I can plug it back into the original equation up here. So that's going to be 2, 4 squared minus 3 times 4 plus 1 over 4 squared plus 4 minus 12. Now, I've got a handheld calculator that I'm just going to throw this in real quick. So you're not going to be able to see me doing the calculations, but 2 times 4 squared minus 3 times 4 plus 1, that top is 21. And the bottom, 16 plus 4 minus 12 is 8. So basically what we've done is we've created an ordered pair that is 4. And then I'm going to show you, well, you can't see it, but 21 divided by 8 is like 2.6. It's a little bit of a, that's a little bit of a rounding there, but it's approximate, 2.6. So what that's done, Regina, is it allows me, well, let me get rid of some stuff. All right. It allows me to plot another point at 4 and 2.6. So 1, 2, 3, 4, 2.6 is like right there. So it's showing me that the graph is going to be in this little zone here. And then the graph has to be down here. So it's going to follow this asymptote up. It's going to hit both of these. And you can see that the graph starts to trend downward. Since it's trending downward, it isn't coming back up. So it continues to go down. And then the graph would therefore diagonally be in this zone up here. I don't need another ordered pair to put it there, but you can certainly go get one if you wanted one. So that is the graph for number 3.
So like when you're picking like a random number, like when you picked 4, does it matter? Like could you have done like -4 or like?
Well, to pick -4, let me show you where -4 is. -4 is right here. So you couldn't have picked -4 because that's the asymptote, but you could have picked -5, which is what I'm pointing at right now.
So does that mean it just has to be past the vertical asymptote?
Yes, it can be on either the left or the right hand side of it. So let me get rid of a couple things. So what I did is I chose any of the X values from here to the right. I just happen to choose 4, and you can choose any of the X values from here to the left. But you don't need any in the middle. You can certainly use some in the middle if you wanted to, but you already know information. You know these points right here exist. So now you're just trying to figure out what's happening over here and what's happening over here.
Okay, that makes sense. Thank you.
You're welcome. Oh, I guess I can't put that back up. So there's a rough sketch of it real quick. All right, on to number 4. Now, what you guys will find out is I'm actually more patient with you when you're asking questions than I will be if you're not asking questions. All right, your 30 seconds is up there. So we'll move on to number 5. Make sure when you have a hole that I can see through it. I should be able to see white space through the hole. All right, so that's the graphs from 1 through 5. You were also supposed to do the fill in the blank at the bottom of page 5. So let's go through those now. Now, they even gave you a word bank. So it wasn't even like that hard because they told you what to be using down here. So number 6, the first step in graphing a rational function is to blank the numerator and denominator and simplify the equation. So what word, we're going to fill in the blank right there.
Factor.
Good job, Jerry. Factor. Number 7, when the equation is simplified, factors that blank create holes in the graph. Let's get rid of factor. There we go. Factor's gone. Factors that blank create holes in the graph.
Eliminate.
Eliminate, Regina. Good job. Number 8, determine the equation of the vertical asymptotes by setting the blank equal to 0. This would be the bottom of the equation. So what's the bottom of the equation called?
Denominator.
Good job. Now, don't let Regina answer everything, guys. Come on. There are approximately 19 of you here, so you should be able to answer these. 9, determine the horizontal asymptote by comparing the blank of the numerator and denominators.
Degrees.
It's the degrees. Good job. Number 10, find the x-intercepts of a rational function by setting the blank equal to 0.
Numerator.
The numerator, Maddie. Good job. And number 11, determine the y-intercept of the function by substituting 0 for what? Oh,
X.
X. That's right. Put a 0 in for X and it will find the y-intercept. Good job. Now, oh, gotta have the pen. So this bottom of page 5 can actually help when you're, struggling, like, oh my gosh, I don't know how to find a horizontal asymptote. So what do? Oh, that's right. I compare the degrees. So, keep this filled in and you can use it when you're taking your test this weekend. All right. So after pages 4 and 5, you were asked to find the holes, intercepts, and asymptotes for pages 7 and 8. So here are the holes, vertical asymptotes, and intercepts for number 1. And if you need to, like, I don't know how he came up with that y-intercept, you would just ask a question and we'll go over it. Why is there no slant asymptote? How do you get half for horizontal? Anything you need to ask, because you got tests coming up this Friday. And if you miss something, then go ahead and adjust it, because tonight's homework is you're graphing pages 7 and 8. So you're going to want to have these correct so that you can graph the right thing over tonight, tomorrow, whenever you're going to do it. Now, when you get to number 2, you were told to eliminate this 4 in the front of the denominator. And if you didn't eliminate that 4, then all your answers would be completely wrong. Well, not all of them, a lot of them. So like, how did he come up with that slant asymptote? Where did the hole come from?
Yeah, can you go over how you got the hole?
Yes, sir. All right. So we have to factor the I have to factor the top and the bottom because you told me that's the first thing we're going to do. So the top factors with a GCF. And then it factors again because you have difference of squares. The bottom, you got to get rid of the 4, otherwise this doesn't work out very well. So if we do it the way we're supposed to, it has a GCF of x, and then it's just x minus 4. So
Yeah, I had a 4x minus 1. Well, no, 4x and then in parentheses, x minus 1.
All right. So don't make me do this to you, man. You can't see that. Let me share. I got to change my screen. All right. Algebra 2 notes. Tuesday, October 27th. First thing we did on Tuesday when we were here, it's right here in the middle. Adjustment needed. Number 2, denominator, x squared minus 4x. That first 4 shouldn't have been there.
Got it.
Now, number 4 and number 6 also are going to make adjustments. So hopefully you made those adjustments. I don't know if you did or not, but you need to, okay? So now, what did I do? All right. All right. Back to your problem because you asked me, so I'm going to finish it up. The x's cancel. And so what that does is it gives me the 0 for the x value. And then, so let's see. It's gone here too, right? That's not there anymore. So this 0 gets plugged back into the problem. And so it can actually go into either one of these two. And this one is the simplest one right now to plug it into. So if I put a 0 here and a 0 here, then this is what I get. 9/4. Now, if you hadn't made that adjustment, you wouldn't have the same hole. It would be different.
Yeah.
So, but that's how I came up with the hole. Anybody have any other questions about slant asymptote? Any of the other stuff that's up here? Because this would have been the very first slant asymptote that you guys would have had to come up with.
Can you do the slant asymptote for that one?
All right. So Niskaya, again, I could use either one of these two versions. This just happens to be the better version to do to find the slant asymptote with. And so what we're supposed to do is divide. And I can use synthetic division to do this with. Hey, does it sound like, am I yelling at you? Am I loud?
No.
Okay, just want to make sure. So 4, I feel like I'm yelling. 1, 0, -9. You know where the 0 comes from?
Yeah.
Okay. So we dropped the 4. Sorry, we dropped the 1. I didn't mean for that to be yellow. Drop the 1. 4 times 1 is 4. 0 and 4 make 4. 4 times 4 is 16, but nobody cares because we don't use the remainder. So what we have left is a y equals 1x plus 4 equation that is our slant asymptote.
Will we have to use long division in the test?
Well, here's the thing. I hope not. But it is a Delta Math test. So the problems are randomly generated. And so I can't guarantee that you won't have one.
What makes it what makes it that you have to do the long division?
Gotcha. All right. So if this had this 4 back in there, then I would have to do synthetic division. I'm sorry, I would have to do long division. In order for us to do synthetic, the leading coefficient has to be 1 and the degree has to be 1. Both of those have to happen.
Got it. Thank you.
So if this is a 4, yeah, sorry, dude, you're going to have to use long division, okay?
Got it.
But hopefully you won't have that. All right, let's move on to number 3. Number 3, you don't have to change anything originally. Everything was okay. You just had to find everything. All right, gonna move along. All right, number 4, Jerry, the denominator, x minus 4. I don't know if you have that, but if you guys didn't adjust your denominator here, you won't have what you need. Again, you got another slant asymptote. You got 2 x-intercepts. You got any questions? Let me know. All right, moving on to number 5. Nothing needs adjusted. We're good to go on this problem. We've got a hole. Make sure we know how to get that hole. There will be questions on the test that are just, hey, find the hole. Again, this is your homework tonight, is to graph these problems. So if any of your information is incorrect, you're going to want to make sure you adjust it so that your graph will be okay, or has a chance to be okay. No questions means we move on. And number 6, denominator need to be adjusted, x minus 1. It's got another slant asymptote. I graphed this for somebody last period, so my vertical is sitting there.
Oh, sorry. I had a question on 5.
All right, people, hang on. We'll be patient. Hey, Jerry, just be patient. Let everybody look at this, and then we'll go back.
Yeah. Mhm.
So if anyone has anything about number 6 they want to ask, let's go ahead and knock that out, because I know Jerry wants to go back to number 5. All right, let's go back to number 5. All right, Jerry, what you got?
So for 5, I got, for the horizontal asymptote, I got y equals 0.
Okay. So now you said horizontal.
Yeah.
Okay. So let's see. Let me see if I can go back to Monday. Oh, you can't see this. All right, so these are last Monday's notes, okay? So we'll go back to right here where it says horizontal asymptote. All right, so we're looking for the degree, right? The degree, is the bottom bigger? Are they the same? Top bigger, okay? So where are we? All right, so the degree on the top is 2. The degree on the bottom is 2. So they're the same, right?
Yeah. Oh, so it'd be the leading coefficient.
Right.
Okay.
Exactly. So it's 1 divided by 1, which is 1.
Yeah. Okay. Thank you.
Was that it?
Yeah, I'm not really sure why that happened, but yeah.
That's all right. Quick mistake. Last call for number 6. All right. So here's what we're going to do. We're going to go to page 9. I'm going to erase this. Guess I didn't erase that. Probably didn't erase this either. All right. Page 9. And so this is just one more place to put information. Okay. So we're just going to rehash some of the things that we've already talked about. Just another summary page where it puts it all together. All right, so rational equations have to be in the form P of x over Q of x. So in other words, it's a fraction, right? In order for it to be rational, rational means can be written as a fraction. So we got P, we got one function on top of another function. X-intercepts. All right. So to find your x-intercepts, you're going to factor and solve the top, otherwise known as the numerator. Now I'm going to take that solve word, I'm going to rewrite it because that doesn't look like solve at all. Factor and solve the top. Vertical asymptotes, right? So here, very similar to the x-intercepts, you're going to factor and solve the bottom. So that's why at the very beginning of the problem, you're supposed to just factor. Get everything factored as quickly as possible. On the horizontal asymptotes, this is where we compare the degrees. This is where we look at the degrees. Remember, the degrees are the highest exponents. And so what this first one is saying is the top is bigger. Okay. The middle one says the bottom is bigger. And the bottom one says they're equal. When you compare the degrees, the top is bigger, the bottom is bigger, and they're equal. Now, if the top is bigger, you actually have a slant asymptote and not a horizontal asymptote. So you would hopefully, this is what Jerry and I were talking about earlier, need to do synthetic division to find a y equals mx plus b. If the top is bigger, that's for the top. And so you actually don't have a horizontal asymptote, you would have a slant asymptote. If the bottom degree is bigger, it's automatically y equals 0. No math to do, it's just 0, that's what it is. It's automatically. And if the degrees are equal, then you're going to divide the top leading coefficient by the bottom leading coefficient. And so that's how we deal with horizontal asymptotes. For the holes, so this holes will exist when a factor cancels. And don't forget that this is going to be an ordered pair. And you're going to plug the x in to get the y value. Now, one thing this doesn't have on it, for some reason, is y-intercepts. So if you have a little bit of room, to add in the y-intercept, so here you're going to divide the constants. So I don't know why it didn't have that on there, but that's a pretty important thing. And it's important to our graphing because that's one of the 3 points that we can usually use to graph our equation with. All right, so that's just another summary. Just one more time to go over all that, holes, asymptotes, and intercepts. And so let's check out these graphs. So this first example is, as you can see, I already have my vertical asymptote graph, so I'll get rid of that. So we can do it together. I want you to feel special. Same thing down here. But one thing it doesn't have It forgot, it says like the last one, it did not give me a y-intercept. It didn't give me a place to put y-intercept. So we're going to add that. And this will be one of the first graphs that you see with a slant asymptote actually graphed. All right, so let's go through the process. First thing we need to do is factor. It'll be x plus 3, x minus 3. Bottom x plus 2. All right, so I'm going to ask you guys, do we have a hole?
No.
No hole. All right. That takes us over to, let's do the y-intercept. So the y-intercept here can be written a couple different ways. You can write it as -9/2, or you can just go ahead and call that -4.5. All right. Come on now. X-intercepts. X-intercepts. What are the x-intercepts?
Three and -3.
I'm going to go with -3 and 3 for the order. Jerry, because we should get a -3 from the first one. So based on the way that I wrote it, that's how I'm going to write the answers down. Hope that makes sense. Vertical asymptote. Waiting for any one of the 19 kids that are sitting in class right now.
-2.
Oh, it's not -2. You got to give me more than that. You can't just write that down.
X equals -2.
Thank you, Regina. X equals, because this is an equation. All right, looking at the degrees. Is the top bigger, the bottom bigger, or are they equal?
Top is bigger.
Top is bigger, so we don't actually have a horizontal, we have a slant asymptote. So we get to do some division. So Jerry, you should see that we can do synthetic. Because since you asked me about that earlier. So -2. 1, 0, -9. Now I asked Niskaya earlier today, I said, do you know where that 0 came from? She said, yes, sir, I do. So I hope the rest of you guys do as well. So we drop the 1. -2 times 1 is -2. 0 is -2. Nobody cares about anything else that happens after this. Because we have y equals x minus 2 right here for our slant asymptote. Y equals x minus 2. We don't need a domain and a range. So there's all the holes, asymptotes, and intercepts. Based on the information that we have, what is the first thing that you and I are going to graph?
The asymptotes?
Yes, the asymptotes, because we don't have a hole. Good job. So we're going to go for, oh, that's not right. Come over here, negative. Come on now. Gotta get my pen back. Nope, I want red. All right, now go away. Come on. I was so ready. Negative. Oh. I just want to graph this asymptote. Go away. Go away. Go away. Go away. Go away. It's not going to work. All right, let's try it now. -2. Yay, -2. Ooh, that took forever. All right, now the next one is a slant asymptote. So how do I graph a y equals mx plus b line? We go to the y-intercept. The y-intercept is -2. -2. The slope is 1. So we keep following the slope all the way through the graph because I need the asymptote. I need this imaginary line. It's going to show us how to graph our equation. This one's kind of funky.
Wouldn't the y-intercept be? Wait, I didn't think it was 2.
All right, so what I'm doing is I'm graphing the y-intercept of the slant asymptote,
Oh, okay.
which is -2.
Got it.
So it's the y-intercept of the line, not the y-intercept of, not the -4.5.
Got it.
Okay, so let's see. Verticals graphed, slants graphed. What's next?
The intercepts?
All right, y-intercept, -4.5. That's -2, 3, 4, -4.5. X-intercept's at -3, +3. Now, I know you're looking at that going, I don't know what to do, but everything is here that you need. So I have these guidelines, okay? And the graph has to be over here. That's supposed to be green. Over here and over here. So you're going to use the asymptotes. Those are the asymptotes and those blue dots to help you connect where the graph is going to go. So you follow these 2 points down the asymptote and up the asymptote. And then this point right here is all by itself, but you just follow the asymptotes. Oh, I hope that works. Yeah. So as long as you don't cross over those dotted lines and you connect the intercepts, you should be successful. So if you have a question about that example 1, here we got plenty of time. It's only 1:30. Okay, we'll scoot down here and we'll look at problem number 2. And these are just more examples of graphing so that you can just see more, so you know kind of how to handle it on your own. Remember, we're not doing domain and range at all. You don't have to worry about those. Let's factor. X minus 5, x plus 1, x minus 1, x plus 1. All right, there it is. It's factored. Start giving me some information. What's going to happen?
The x plus ones cancel.
All right, so what does that do, Regina?
It creates a hole.
All right, creates a hole. Do you know what the x value is?
1
Close.
or -1.
-1. All right, so how do we get the y value? Anybody?
X
to get y.
There you go. Plug in the -1 to get the y. All right, we can do that. All right, so we take this -1. We're going to plug it back into here. It's coming back into here. So that's -1 minus 5 over -1 minus 1. So that should be -6 over -2, which is 3. All right, there's the whole. Good job. What else can we do? What else can y'all come up with? You can start right here. You can go with the y-intercept.
You divide the constants.
All right, good job. So right here, divide the constants. What do you get?
5.
5. So that's the y-intercept. Okay, x-intercept, vertical asymptote, horizontal asymptote. Anything you want to give me, guys? Anybody, anywhere? Come on, somebody's got to know how to do something.
You solve the top for the x-intercept.
All right, good
Yeah.
job. So right here, what does that give you?
X equals 5.
All right, that's a 5. Thanks, Jeremy. It takes me a while, Jeremy, to get to this chat. All right, how about the vertical and the horizontal asymptotes? Anybody?
X equals 1
Which one is that, vertical or horizontal?
for vertical.
All right, vertical comes from here. Maddie is correct. That is x equals 1. And we just got one more left, horizontal asymptote.
Y equals 1.
Okay, Maddie, where'd you get that?
Let's see. I got it from the degrees, sorry. It They're both the
No,
same.
well, it's not straight from the degrees. You use the degree
Oh, the coefficients.
to do something else. You have to divide the leading coefficients. So Maddie Ellis, that should come from right here, right? One divided by one. All right, time to graph. See if I can get this right. We'll start with the y because I can get to it. Y equals 1. X equals 1. We have a whole. Should have done that already, probably, right? Let's see. Whole, -1, +3. Let's see, -1, +3, I think is right there. We got some intercepts. X equals 5. Let's see. 1, 2, 3, 4, 5. Y equals 5. 1, 2, 3, 4, 5. And then we have to connect. If we connect the whole, I was supposed to be green, crying out loud. Come on. Green. If we connect the whole to the y-intercept, you'll see that the graph is going up. And so we'll bring it down towards the asymptote. And then in the bottom right-hand zone, we just bring it up through the x-intercept, follow the asymptote. There it is. So I hope, the slant asymptotes are going to be a little tough. It's going to take you some practice to get that. But I hope you guys have a better grasp on graphing. We still have Thursday and part of Friday to keep talking about it. So we have time. I'm going to go ahead and just remind you that we should have all of the holes, asymptotes, and intercepts for 7 and 8 done. Now you're just graphing it. And then you got to do everything for pages 10 and 11. So the goal is to have all of 7, 8, 10, and 11 done by the time you get back to me on Thursday. That's today, tomorrow, and Wednesday to get that done. So are you sure there's no more questions about slant asymptotes? Maybe I can do another one for you.
Yeah, before we go, can you do one that's like we don't originally have 3 points to plot on the graph and you need to like plug in an x value, because I was struggling with those.
Okay, so here's one. This is number 3. This is probably page 7.
Yeah.
So you have 2 verticals. Whoa, this is going to be fun. You don't have a whole, you have 1 x-intercept and 1 y-intercept. So let's check this out. This is what you want right here. This is a good one. So Merry Christmas early or Happy Hanukkah, whatever. Here's a present for you. It's part of your homework. All right. So vertical asymptote, -3. X equals 2. Y equals 0. So you're going to have stuff going all over the place, okay? All right, x-intercept is at 1. X-intercept's at 1. Well, that's kind of crazy. Y-intercept's at 2/3. So those are the 2 points that were given that are plotted. Okay, so far so good?
Yeah.
Okay, we need more information, don't we? So let's see, 1, 2, this is 3, 4, 5, 6, 7, 8, 9, and 10. Okay, pick one of those. Pick any one of those numbers, 3 to 10.
6.
6, okay. All right, so you're going to take 6. You're plugging it back into here. So I'm going to sneeze. Woo! Excuse me.
Bless you.
Thank you. All right, so this top, 24 minus 4 is 20. On the bottom, these two 6s cancel each other out. It's 36. Each one of those are divisible by 4. So that's 5 over 9. So that's pretty small. It's not quite 1. So what we did, Jerry, is we just figured out that the graph is going to be about right there.
Okay, got it.
Now, what that does for me as the grapher, it tells me it's going to be like this.
Okay, what about if like the x-intercept is on the asymptote?
Well, I know what's going to happen, but you just don't know what's going to happen, okay? So let's check this out, all right? Let me do another point for you because that's where you were like, I need to see where I need to plug in another point. So we're going to do that one more time, all right? This time, we're going to come over to the left-hand asymptote. It says 1, 2, it says -4. I'm going to skip -6. That's like -8, okay? So you can pick any number that's over here.
Got it.
What do you want to pick?
-8.
-8, all right. So you're coming back to the equation, -8 minus 6 is -4. It's supposed to be -4. -8 squared minus 8 minus 6. Now I can't do all this in my head. I'm pretty well. The top is going to be what, -36? -36. Bottom, oh, okay. So that's 64 minus 14, that's 50. So both divisible by what, 2? So -18 over 25. That's going to be, it's not quite -1. So -8, so it's going to be like something like that right there. So does that part make sense? That's what's right here.
Yeah, that makes, yeah.
So check this out. This should be telling you now, Jerry, that the graph does this.
Okay, yeah.
Now think about this. This rule of the diagonal. So from this point right here, is it going to go, like, tell me how it's going to go. It's going to go down to the left, down to the right, up to the left, up to the right. What's it going to do?
It's going to go down to the right.
Good, exactly. So, but these two have to connect to each other, and it goes down to the right. So what's the rest of it do?
Oh, and then the top goes to the left.
Yeah, exactly.
Okay.
So this is a weird one where when the x-intercept is on the asymptote, it actually crosses the asymptote. So it becomes this, what we call a cubic in the middle here.
Got it.
Math is weird sometimes. You know, it's like not really supposed to do that, but it does it. So good job. Everybody needed to see that. So I'm glad we did that. So guys, there's number 3 on your homework for you. Merry Christmas, Happy Hanukkah, Happy Kwanzaa, Happy Thanksgiving, Happy birthday, whatever. There's one for you. All right, anybody else got anything? All right, gang. Have a great Monday, Tuesday, and Wednesday. Make sure you get all this done so we can talk about it on Thursday and get you ready to ace this test on Friday, guys. Y'all have a good day. I'll see you Thursday.